Okay, everyone, this is lesson 8.1 for Algebra 1. We're looking at factors and greatest common factors. Let's start with our warm-up. So our first directions tell us to state whether the second number is a factor of the first number. So what they mean is, does this second number go into the first number evenly? Can we divide this second number into the first number evenly? 6 does not evenly go into 50, so this is no. Let me ignore that. Hold on. Okay. For our second one, does 7 go into 105 evenly? Let's check. 7 goes into 10 one time, the remainder of 35, and then it goes into that 5 times. So we have a remainder of 0, so therefore it does go in evenly. So yes, 7 is a factor of 105. For the next one, it wants us to list all the factors of 28. So all the numbers that can be divided into 28, and we usually start with the smallest number. So 1 is a number, and it says to list the positive and negative. So that means positive and negative 1 go into 28. The number 2 does, so positive and negative 2. The next number that goes in is 4, so both positive and negative 4. The next number isn't until 7. Then 14 goes into 28. And finally, 28 goes into 28, goes in one time. So we have all the positive and negative numbers. And you can use this little sign, the plus or minus, to say both numbers. Okay, finally, tell whether each number is prime or composite. So prime means that number can only be divided by 1 and itself. If it's composite, they want us to write the number as a product of 2 other numbers. So any factors that go into it. 11 cannot be divided by anything other than 11 and itself. So it is a prime number. 98 can be divided by another number. I always like to look at a number, and if it's even, I know right away that it can be divided by 2. So therefore, it's automatically a composite number, and I'm just going to do the easiest one for me is 2 times 49. Those are 2 of the numbers that can go into 98. You could have done, you shouldn't do 1 and 98 because that goes into a prime number. You should pick something other than 1 in itself. So today we're going to look at writing the prime factorization and then finding the GCF, which stands for greatest common factor. And you'll hear the terms prime factorization and, like I said, greatest common factor. So the whole numbers that can be multiplied to find a product are called the factors of that product. So a number is divisible by its factor. So what numbers go into that? So for example, the number 12, our different factorizations are, we can do 1 times 12, we can do 2 times 6, we can do 3 times 3, we can do 1 times 4 times 3, or we can do 2 times 2 times 3. All of these numbers here are factors of 12. They all go into 12 evenly. That's the key. They have to go in evenly. The order of factors does not change the product, but there's only one example that cannot be factored any further, meaning no other numbers, we can make it go into those other numbers. So this is called the prime factorization because we can't divide the numbers 2, 2, and 3 any further. On this one, we could have divided 12 further into 6 and 2, and then 6 we could have divided into 2 and 3. So the prime factorization are all the prime factors that are written in any order. So all the numbers that are prime numbers that go into that other number. Like I said in the warm-up, a prime number has exactly 2 factors, just itself and 1. And a number 1 is not prime because it only has the factor 1. Okay. So we're going to look at writing the prime factorization. There's 2 methods. You can choose either one. The first one is the factor tree. This is the one I always use. So you start with the number and you pick any 2 factors that go into it and you make a branch. If it's even, I think the easiest thing to start with is 2 and whatever the other number that goes into it is. So I always, if it's even, just start with 2. This first number, 2, is already prime, so it's done. So we need to break down 49 more. 49 I know can be divided by 7 and 7. So 7 times 7 gets me back to 49. And it actually cannot go any further. So I'm at all my 3 prime numbers. So the prime factorization is 2 times 7 times 7. The cake method, what you do is you pick, choose a prime number of 98. So we can choose 2, that's a prime number. And 2 goes into 98 49 times, and we do a little stair step thing here. Then the next prime number that goes into 49 is 7. So 7 goes into 49 7 times. And then 7 can be divided by 7 one time. So our factors are 1, 2, 7, and 7. Or you could say 7 squared. If you don't write the 1, technically you don't have to. Everything can be divided by 1. So if you write it, that's fine. If you don't, that's fine also. So if you just wrote 2 times 7 times 7, you would get full credit for that. So we're going to write the prime factorization of each number. Like I said, I like to start if it's even with 2 and the other number that goes into it. So I'm going to do 2 and 20. 20 I know can be broken down into 4 and 5. And then I know the number 4 can be broken down into 2 and 2. So my prime factorization is 2 times 2 times 5. Okay, 33, I know that 3 and 11 go into it. That's just, looking at it, I can see it's divisible by 3 11 times. And then 3 and 11 can't be broken down anymore, so the prime factorization is 3 times 11. Okay, factors that are shared by 2 or more whole numbers are called common factors. The greatest common factor is the biggest number that goes into both numbers, that can be divided into both numbers. So to figure this out, sometimes we want to start by listing all the factors. So all the numbers that go into 12 are 1, 2, 3, 4, 6, and 12. All the factors of 32 are 1, 2, 4, 8, 16, and 32. So the greatest common factor is the biggest one they have in common. Well, the ones they have in common are 1, 2, and 4. The biggest number, of course, is this 4. So the greatest common factor of 12 and 32 is 4. So we want to find the greatest common factor of 60 and 100. So the prime factorization for 100 are all the numbers that go into it. So 1, 2, 4, 5. I know I'm going a little fast. I just want you guys to kind of hang. So yeah, like I said, I'm sorry I'm going fast. I just want you guys, if this is too quickly for you, just take your time. You're writing out all the numbers that can be divided into 100. So after 10, 20 goes into it. We know that 25 does, 50, and then 100, of course. So now all the prime factors, or just the factors of 60, 1, 2, 3, 4, 5, 6, 10. This is actually technically not the prime factorization. I don't know why they're writing prime factorization, because prime factorization, again, means all the prime numbers that goes into this. We're actually listing out all of the factors right now. So I really don't like how they have that listed. 12, 15, 20, 30, and 60. The biggest number that goes into both of them, if you look, is 20. So the greatest common factor is 20. Okay, the GCF of each pair of numbers. So I'm going to break this down into 2 and 13. And then 52 can be divided by 2 and 26. And then 26 can be divided by 2 and 13. So the greatest common factor is actually 26, because 26 goes into 26 and it goes into 52. It goes in 2 times. You can also find the greatest common factor of a monomial if it includes variables. To do this, you would write the prime factorization of the coefficient. So that's the number out in front. So if I have like 6x squared, this is the coefficient. And then you write all the powers of that variable. So what they mean is you would write 2 times 3, and then x can be split up into x squared can be split up into x times x. Okay? So we're going to write the, if there are 2 different terms that contain the same variable raised to different powers, the GCF contains the variable raised to the lower power. So I'll show you what I mean by that. So we can break 15 down into 3 times 5 times x times x times x. We can break 9 down into 3 times x times x, just 2 x's. So we have a 3 in common, and then we have 2 x's in common. So 3 times x is the greatest common factor, which is 3x squared. So the other way of what they were saying on the last slide is that you look at the powers, if it's this, as long as it's the same variable, and whichever one has the smaller power, that's going to be your power on the exponent. And then you just choose the greatest common factor of that coefficient. So it's 3x squared. So for this next one, looking at 8 and 7, I know that 8 can be broken down into 2 and 4, which 4 can be broken down into 2 and 2. 7 can be broken up into 7 and 1. So our greatest common factor for the coefficient part is just 1. That's the only thing in common. 1 is the only number that goes into 8 and 7. And then looking at the variables, they're not even the same variable, so you can't even use the same common factor of the variable since it's an x and a y. So there's no common variable. So the only thing that is the greatest common factor of 8x squared and 7y to the third is 1. All right, we're going to do a word problem, and then we are done. So a cafeteria has 18 milk cartons and 18 chocolate milk cartons and 24 regular milk cartons. The cook wants to arrange the cartons with the same number of cartons in each row. Chocolate and regular milk will not be in the same rows. They want chocolate milk in rows, and they want regular milk in rows, and they want to have the same number of cartons of each in each row. How many rows will there be if the cook puts the greatest possible number of cartons in each row? So basically they're asking that the 18 chocolate and 24 regular milk must be divided up into equal group sizes, and the number of cartons in each row must be a common factor of 18 and 24. So we need to list out the factors of 18. So all the factors of 18 are 1, 2, 3, 6, 9, and 18. And all the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. So the greatest common factor here is 6. So that means that the greatest possible number of milk cartons in each row is 6. So let me draw a little picture, okay? So we know that for the chocolate milk, there's 18. So we're going to list, he's going to line those up into rows of 6, if that makes sense. And if you notice, we can only have 3 rows to get to 18, okay? So there's 1 row, there's 2 rows, there's 3 rows. So we know that we need 3 rows of the regular because 6 goes into 18 3 times. For the 24 regular milk cartons, we need to see how many times does 6 go to 24, and it's 4 rows. So we're going to have 3 rows of regular milk or chocolate milk and 4 rows of regular milk. So the greatest number of total rows are 7. We've got 7 total. Okay, so again, it was just finding the greatest common factor. And if you guys have questions, we will go over this in class.